Okay, here we are. Algebra 1, 4-8. Got a little Chicago Cubs action going on in the background. Go Cubs go! Go Cubs go! I hope we're still singing that song. That means they're still in the World Series. Alright, they're up 1-0 right now in Game 2, in case you're wondering, and I know you all are. Alright, let's go ahead and do 4-7. I think I said 4-8, but I meant 4-7. So 4-7, this is for Algebra 1, 4-7, is transforming equations. Okay? What this is, transforming equations. Remember, you all have your notes out, and you are all being active learners. Got it? Active learners. Okay, now. Oh man, knocked it loose. All right. So 4-7 is transforming equations. What we're going to be doing is we're working with equations, but these are going to be with a bunch of variables, okay? Now, that generally creates some concern, but we're going to do the same stuff that we've done before for the most part in solving equations, but it's just got variables instead of numbers. So let's just do some examples here. We're going to solve for the, I'm going to say given variable. It actually is the variable in color, but for your note taking you may not have color, so I'll show you how we're going to solve. So if this is capital F equals MA, we're going to solve for A. So here's our equation, capital F equals MA. We're going to solve for lowercase a. Okay? So, how do we solve for A? Well, our goal is we want to isolate the A. So, again, pretend this is a number like 7, this is a number 4, doesn't matter. If you wanted to isolate the A, you look at what's attached to the A. And we say, okay, what's attached to the A? M times A. So the opposite of multiplication is? Yes! Very good answer. Way to go, Mackenzie. That was awesome. You divide both sides by M, because you want to isolate the A. M over M cancels, and we're left with F over lowercase m is equal to lowercase a. You have solved, given. You have solved for A. Now, the symmetric property allows me to say A is equal to capital F over little m. And then you're done. You've solved for A. So it's the same operations. Okay, so A is attached with multiplication to M. You want to get rid of them. You divide the M out. M over M is 1. F over M. Here we go. Okay, let's do another example. Number 2. What if I have S, capital S is equal to N over 2 times A plus L. Okay, and then we want to solve for the variable N. Now the variable N, okay, we see it there. A lot of people, what they want to do is they want to distribute this into the A and into the L. I would not, okay? What I would do actually is I would look and say, well, I have N over 2, and then that is attached with multiplication. So when it's attached with multiplication, if you want, our ultimate goal is to solve for the N, and we also look at it's attached with 2 with division. I'm going to leave the N over 2 by itself. I'm not going to worry about the 2 yet. I'm going to look at the A plus L and say, I want to get rid of it. Well, if it's attached with multiplication, how do you get rid of something? Just like we did before with the M and the A, we divided by both sides by M. So in this case, I want to get rid of the A plus L, it's attached with multiplication, so I'm going to divide both sides by a plus L. Now you can do that because again, it's attached, the whole thing is attached with multiplication. So I divide both sides by a plus L. And a plus L divided by a plus L, what happens? It cancels to be 1. So now you have capital S over a plus L is equal to n over 2. Now, I want to solve for n. So I have n divided by 2. How do you get rid of the 2? Yes, good work, Gregor. You multiply both sides by 2. And if it helps, we can put it in fraction form. That sometimes helps, 2 over 1. Now we say 2 divided by 2 cancels. 1 times the denominator is going to stay just as a plus L. So I'm going to leave it as a plus L on the bottom. And then the top is 2 times S, so 2S. Symmetric property states for us n equals 2s over a plus L. I've solved for n. That was my goal. I've solved for n. And so in which case, I'm done. Let's do another one. Number 3. If you have a equals v minus u over t, and we want to solve for v. Alright, what do I need to do there? So I have a equals v minus u over t, I want to solve for v. Well, the issue is that I have v minus u, but then it's all divided by t. We can't add the u because we want to isolate the v. We can't add the u because the whole thing is divided by t. So I need to get rid of the t first, and then I can deal with the minus u. I'm going to rewrite it so I have a little more space here. How do I get rid of the t? Well, look, the whole quantity v minus u is being divided by t. The opposite of division is multiplication. So we multiply both sides by t. And then t over t, that cancels out to be 1. And I, again, usually do alphabetical order. So at is equal to v minus u. Now, I want to solve for v. I want to isolate v. What do I have attached to the v? I have v minus u. So how do I get rid of the u? Keanu. Okay, yes, good, Keanu. Also, you can take your feet off the chair in front of you. Good. So add the u to both sides. And so what I have is at plus u is equal to v. Because the negative u and positive u cancel. At plus u. So I've solved for v now. It is at plus u. And that's why I put a little curve on the t to keep it so it doesn't look like plus plus. Alright. Let's give you another one. This way you have a real good tool bank of things to, examples to look at when you're solving these. So number 4. What if I gave you capital C is equal to 5/9 times f minus 32. Now you might recognize this one. If you do, it's because it's a Celsius Fahrenheit conversion formula. Alright, so I want to solve, I didn't tell you that yet, sorry. I want to solve for f. So if I want to solve for f, a lot of people make the error and they say, oh, okay, if I'm going to solve for f, I'm going to add 32 to both sides. Well, the issue is you can't add until you deal with this multiplication of 5/9 on the outside. So you can either distribute the 5/9 in, which I wouldn't recommend, because then we have a 5/9 f, and then we have 32 times 5 divided by 9. It's a big number we don't want to deal with. So what I would actually do here is I'm going to rewrite it. In order to get rid of the 5/9, which is attached with multiplication, you could divide the 5/9, but I don't like dividing by fractions. Why don't I like dividing by fractions? Well, I don't like dividing by fractions because you have to invert it, flip it, and multiply. So what I'm going to do is I'm going to multiply right away by the reciprocal. I have to kind of squeeze it in. I'm sorry about that. I'm going to multiply by the reciprocal, so 9/5. So now, 9's cancel, 5's cancel, and you're just left with, okay, 9c over 5, or 9/5 c, either way is fine, equals f minus 32. Our goal is to solve for f, so now I look and I say, what do I have attached to the f? I have a minus 32. You're going to add the 32 over. So now you have 9c over 5 plus 32. Now, I'm going to write it as 32 over 1 is equal to f. If they want a common denominator, which sometimes they might, let's do a little adding fractions. What's our common denominator going to be? Well, our common denominator for these is going to be 5. So I multiply. I'm going to bring this up here. F equals 9c over 5 plus 32 over 1. You multiply top and bottom by 5 over 5. So f equals 9c plus something all over 5. What's 32 times 5? Remember, active participant. So you can do, I'll have to squeeze it in here, 32 times 5. You can do long multiplication, 10. 5 times 2 is 10. 16, so 160. At that point you are done. You cannot combine 9c and 160 because this doesn't have a c. There's not a same base. So we leave it as such. Okay. So another one. Number 5, hang in there. I know. You will survive. Maybe. No, you're going to make it. You're going to make it. So L equals A plus n minus 1 times D. We want to solve, move this out here, we want to solve for n. So L is equal to A plus n minus 1 times D. We want to solve for n. So I have to look and say, okay, what are the things attached to the n? Well, I have the multiplication of the D. And then I have the A on the outside. I also have the minus 1 on the inside of the parentheses. Okay, let's walk through a couple of errors. One error would be if you tried to add the 1 to both sides. You can't add the 1 because it's attached with multiplication with the D first. So you can't add the 1 to both sides. So that would be an error. The other error is if you say, oh, well, I have multiplication of the D, so I'm going to divide both sides by D. Okay, maybe I should do that in pencil so I don't accidentally. Okay, if I divide both sides by D, oh, perfect, I divide by D. The issue is that this whole quantity is attached, okay? It's attached with addition to the A. So if you divided this by D, you also need to divide the A by D, which can work, but it makes it a little bit more difficult in the end. So we don't want to do that either. So I'm going to erase, we don't want to divide by D. So the first thing we need to do is, let's go ahead and just subtract the A. And that is mathematically legal because the A is standing by itself, and we're just going to subtract it from both sides. So we're going to get L minus A is equal to, we got rid of the A's, n minus 1 times D. Now I look, I have n minus 1. If I try to add the 1, the issue is I have this multiplication of the D. I can't just add the 1 because it's attached with the multiplication of the D. Here, the A, the reason why I was able to subtract the A is it wasn't attached with the multiplication of the D. That was all over here. So what I need to do is divide both sides, because it's multiplication of the D, divide both sides by D, like that. So then you have L minus A all over D is equal to n minus 1. Because those D's cancel, D over D. Now, what is next? I need to isolate the n by adding 1 to both sides. So you have L minus A over D plus 1 is equal to n. And typically we will see that as n is equal to L minus A over D plus 1. Now the book may have, I'm going to put note, the book may have D can't equal 0. We've seen this before with some of the problems we've done. The reason why D can't equal 0 is because you can't divide by 0. So if D was 0, you'd have division by 0, which you can't have. So we say D can't equal 0. If you forget that D can't equal 0, I'm still going to give you credit. You can try to work on it. The variable, the denominator can't equal 0. So that's why D can't equal 0. So this is the key right there. But if you add that, that's awesome if you catch on to that. Okay, let's do one more and then you're going to work on homework. Number 6. And let's do capital S is equal to A minus RL over L minus R. And you want to solve for L. The issue with this one is you have an L in the denominator and in the top. So we want to get this out of the denominator and then see if I can't combine it with this somehow. Okay, so the first thing I'm going to do, I'm going to rewrite it so we can work with it. A minus RL all over L minus R. The first thing I'm going to do is multiply. The whole bottom is, okay, L minus R. So I'm going to multiply the top by L minus R and then this side by L minus R, like that. Okay. Then what I'm going to do is I'm going to cancel the L minus R's out. And then I'm going to have, I'll rewrite it here just so we can see it. L minus R times the S, capital S, is equal to A minus RL. Now, there's a couple different routes we could go, but let me show you this. Let's go ahead and distribute the S in, so we get S capital L minus SR is equal to A minus RL. And we want to get our L's on the same side together, so let's go ahead and add the RL over. Add the RL over. So I'm going to get a positive RL plus capital SL minus SR, that's all those three terms written here, is equal to A. So now I've got my L's on the same side. I'm going to add capital SR over. And so now I get RL plus SL is equal to A plus SR. Now here's the trick. I'm going to rewrite this up here. That's not the trick. RL plus SL, capital SL I should say, is equal to A plus capital SR. The trick is this. I have an L here and an L here. I need to factor it out, which means take it out front. We haven't worked with this a ton, but we will. I need to factor it out front, and so L and L, I can take this out. It's the opposite of distribution, so we have R plus capital S is equal to A plus capital SR. Now if I look at that, this is called factoring the L out. And the reason why it's factors is it's L times something, and that's what factors are, 2 things or 3 things multiplied together, or 4 things. So if you took the L and you distributed back in, L times R is LR, L times S is SL, which isn't that what I have right up there? It is. So now that I have L on the outside, it's just one L. It's attached with multiplication. To get rid of the R plus S, I divide both sides by R plus capital S, R plus capital S. R plus capital S divided by R plus capital S cancels. So I'm left with L is equal to A plus SR over R plus capital S. The book is going to, tell you that R can't equal a negative capital S. That's the note. If you didn't get that part, that's okay. The key is to have this part right here. The reason why R can't equal negative S, if it's negative S plus S, it would be 0, and you can't divide by 0. All right, that's one of the hardest ones you'll see. All right, so don't panic if that's a struggle. That's the hardest one you'll see. I can help you out when I see you on Wednesday or Tuesday. Come in for help on Tuesday at lunchtime. I look forward to seeing you. All righty, Cubs are still up 1-0, by the way, top of the 3rd inning. Good luck.